So our last rules for naming are going to be for naming compounds called acids. Acids are compounds that produce H+ ions in solution. H+ acts as a cation in the compound. So this isn't all the time true, but for the purposes of our class here, we're going to look at making ionic compounds with H+ where that is always the cation. So for acids, H+ is specifically the cation. What happens with acids is that they get dissolved into water, so they make a solution, and the H+ ions are then floating around in solution. So a lot of times with acid, because they are in solution, you'll see a phase with them. A lot of times you'll have your acid with the phase AQ after that. That means dissolved in water. So compounds that you can dissolve in water where you have H+ as the cation form these things called acids. Okay, so there are kind of 2.5/3 types of acids, and each type of acid has a set of rules for naming them. So the first type of acid is called a binary acid. So a binary acid is an acid that does not contain oxygen. So a vast majority of binary acids are formed from elements. Okay, so a lot of the anions on the periodic table, especially our halogens, a lot of these here will form acids, and so they're called binary acids. So our halogens all form acids with hydrogen, oxygen a little bit, sulfur sort of, but then as you kind of move away from the halogens, they don't really tend to form acids so much anymore. But this also, so the elements and any polyatomic with no oxygen would also count. So what we're going to see for the most part for these ones, there's only a couple. So we're going to see cyanide quite a bit. Let's see, on your chart, it looks like the only one that doesn't have oxygen is cyanide. So there are more out there, but for the list in your book, it would just be cyanide. Okay, so making the formula is easy. We just take H+ and form it together with whatever element we're using or cyanide. But for naming, we use the prefix hydro is added to the root of the anion's name. Then we use the suffix -ic with the anion, and then we put the word acid at the end. Okay, so we'll go through those with an example. Here's probably easiest to see. Write the formula and name of the acid formed from bromide. So bromide is a halogen, so it forms a -1 charge. So our cation for an acid is always H+, and bromide is Br-. So it forms HBr to show that it's an acid. Again, oftentimes we'll put AQ at the end of the formula to show that it's not the molecule HBr, it's the acid, it's been dissolved in water. So formula pretty easy. The name, we're going to follow our rules. So bromine is our sort of root anion name. So we're going to put hydro in front of that. So then we're going to have our root, which is bromine, but it's not going to be bromine. We're going to change the -ine to -ic. So hydrobromic. So hydrobromic, and then we follow it with the word acid. So HBr is hydrobromic acid. Okay, so that would be the same for any of the acids in this type, hydroblankic acid. So that's sort of a good template. Yeah, hydroblankic acid for all of this type, where the blank is filled in with the root word, the root of your anion. So it could be hydrobromic, chloric, fluoric, or this one, cyanic acid. Okay, so the next types are going to, if this one type had no oxygen, does not contain oxygen, the other two are going to be polyatomic ions that contain oxygen. So polyatomic ions that contain oxygen are called oxyanions. So making an acid with them, they're called oxyacids. So contain oxygen. So we're going to have two varieties. We talked about before that on the chart of polyatomic ions, our two endings are ate, and our other ending is ite. So we have ways of naming ates and ites. So for example, I'm going to pull the polyatomic ion chart back. So if we take a look at this, I'm going to clear, sort of erase what we had worked on before. Okay, so if we look, we can make an acid with nitrate and nitrite. So we have NO3 minus and we have NO2 minus. So our next system of naming is going to designate between the acid made from NO3 minus and NO2 minus. So we're going to have a slightly different naming scheme because, again, we want to designate between the acid made of nitrate and the acid made of nitrite. So if you look, a lot of our polyatomic ions have an ate and an ite. So we have chlorate and chlorite, we have sulfate and we have sulfite, we have phosphate. We do also have phosphite. It's not listed in your polyatomic ions, but that also does exist. And we have hydrogen bisulfate and bisulfite. So again, we want to be able to designate between all the ates and the ites of your polyatomic ions. So that's where these next two rules are going to do, designate between those two polyatomic ions. Okay, so we'll start with the ates first. So oxyacids where the anion is an ate. So there's no prefix, so we take the anion's root and have the suffix "ic", and then we put the word acid at the end. So no hydro in this case here, just blankic acid. So that's going to be sort of our template for this here. We're going to have blankic acid. Okay, so write the formula name of the acid formed from sulfate. So sulfate is SO4 2 minus. Okay, so that's our sulfate. So it's an acid, so we know our cation is H plus. So H plus and SO4 2 minus. So to balance this out, we need two H's for that. We get H2SO4 AQ. So that's our formula for our acid formed of sulfate H2SO4. Okay, so for the name, excuse me, the root of sulfate, we're going to put in here with ic. Okay, so two exceptions to this are sulfate and phosphate. So instead of this being sulfic, taking the ate out and putting ic, it's going to revert all the way back to the name of the element that isn't oxygen. So instead of being sulfic acid, it's going to be sulfuric acid. So it's going all the way back to the name of this. And that's also true if we would have had phosphate here. It wouldn't be phosphic acid, it would be phosphoric acid. Okay, but everything else is fine for the most part. Chloric acid, nitric acid, those ones all are the same, follow this rule. Okay, so this one is sulfuric acid. So blankic acid, sulfuric acid here. Okay, so next we have the ite variety. So for the ite variety, instead of using the suffix ic, we're going to use the suffix us. So the name general sort of template for this is blank us acid. Okay, so blank us acid. We're not using the hydro. Hydro is only for that first type of acid we talked about. Okay, so for example, the formula and the name of the acid formed from nitrite. So if you look at your polyatomic ions, nitrite is NO2 minus. an acid, so we know it's H+. So our formula is HNO2, where again we have AQ to show that it's an acid. So our name, blank us acid, our root, or it's a nitrite. So we're going to have nitrous acid. So we had the root that we put in here, the us ending with acid. So the ite polyatomic ions get the us ending for the acid. The ates get the ic for the acid there. Okay, so that is naming acids. So kind of 3 rules we use for 3 types of acids are do not contain oxygen, are contain oxygen, name ends in ate, contain oxygen, and name ends in ite. Okay, so one sort of last thing to end naming. So at some point, you are just going to be given a general list of compounds, and they're going to ask you to name them. So you're going to have to be able to tell which of those 4 different rules we talked about. So there's a couple of things that hopefully you may have seen. So the first thing that designates all of our naming, we can ask, is there a metal? So the first question you would ask yourself if you're looking at a name or if you're looking at a formula and you have to figure things out, is there a metal? That's going to split it in half. Okay, so if the answer is yes, or we have the answer as no. So if the answer is yes, over here on this side, we have our, that we talked about, our type 1, and we have our type 2 metal compounds. If the answer is no, you're looking at molecules and you're looking at acids. Okay, so we've just divided essentially our naming system into kind of 2 categories just by looking to see if there's a metal. So the next thing you can ask is, do I know the charge? So do you know the charge of the metal? Okay, so if your answer is yes, we have type 1. Okay, so if your answer is yes, do you know the charge? You have type 1 where it's just name and then blank, a lot of times ic, or if you have the polyatomic ion right there. If the answer is no, meaning it could be a charge of +2 or it could be a charge of +3 like we saw with our iron. Then we have type 2, and you're going to have your name, your Roman numerals, and then blank ic, or ide. Oh, excuse me, this is ide. Okay, so your type 1, an example of this would be something like calcium oxide. An example for something like this that you would see in this category would be like copper 2 oxide. Okay. With our formula for this one would be CaO, this one would be CuO. Okay, so our formula is the same, but again, with our naming, this is going to tell you, again, if you don't see any Roman numerals there, you're dealing with type 1. If you do see the Roman numerals, you're dealing with type 2. Okay, so over on this side, a question you could ask yourself to separate molecules from acid, does it start with hydrogen? If the formula starts with hydrogen, you know it's an acid. So you're dealing with an acid. No, then you have a molecule. Okay, so for your acid, next thing you're going to have to ask yourself, is there oxygen? Okay, is there oxygen? Okay, so if your answer is yes or no, yes and no, then if the answer is no, you're going to be dealing with the hydro blank ic acid. If your answer is yes, you're going to have blank ic acid or blank us acid. Okay, so this is our oxyacids, where if it's an 8, it becomes an ic acid, and if it's an ite, it becomes an us acid. And if it's no, then we have the formula hydroblankic acid. So if it's a molecule, then you're going to use your mono, di, tri, tetra, dot, dot, dot. So if you have a molecule, again, it's probably not going to have hydrogen. It can have hydrogen, but it's not going to start with hydrogen. We start molecules with hydrogen if they are acids. Okay, so a molecule, if it's not an acid, it will not start with hydrogen. Okay, so then you're looking at your molecules and you're going to use your prefixes. Okay, so like we did over here, some examples that we saw here, you can have phosphoric acid, which is H3PO4AQ. And an us acid, we could have chlorous acid. So chlorous acid, which would be made from chlorite, which would be HClO2AQ. Something that we could have here would be something like hydrocyanic acid. So hydrocyanic acid, and this would be like, for example, HCnAQ. Okay, and then our molecules, we could have something like dinitrogen, tetroxide. Sorry, that's TET. TE. So something like dinitrogen tetroxide, which would be like an N2O4. Okay, so here's pretty much the whole entire naming in a flowchart. And there's probably one in your book as well. But again, kind of think about doing this on a test if you need to pretty quickly be able to take something that they've given you, either the name or a formula, and figure out what type of rules you're going to need to use to either name it or to come up with the formula of it. Okay, so metals, nonmetals. Again, with our metals, they're either type 1 or type 2, where you know the charge based off of its location in the periodic table, or it's a transition metal and you're going to need to figure that out. And with our things that do not have metals, is it an acid or a molecule? So figuring out your acids and molecules. Our acid naming is a little tough, but again, if you have your flowchart notes, you should be able to follow that. And then our molecules, where we use our prefix system to name those.